here they compare the pricing of Bertrand and Coulomb, right? So it says, from table 1, where it's P1C minus PI Bertrand, because alpha I times gamma square over delta, which is positive, right? So quantities are lower and prices are higher in Coulomb than in Bertrand competition. Okay, so that is the answer from the literature.
Prices are higher, quantities are lower in Bertrand.
Yeah, so quantities are lower and prices are higher. These are the same order of result, right?
You want me to turn on the lights?
No.
Ah, so it's on purpose.
Quantity is lower, pressure higher in Bertrand.
There's a paper in the literature that solves this model of Coulomb Bertrand with differentiating groups with linear demands, Singh and Vives, right? One of the authors is Xavier Vives, who's my good friend and author. I don't know if it's really Carlos Vives, I was amazing.
Definitely be louder.
I mean, Vives has retired, so now he's emeritus, but he's still like very active. You know, he's still like, we have a paper together with publishing, because I think you send it down and anyway, a long time ago, more than 40 years ago, I recently published this paper, when I was 2 years old. Actually, probably when I was 1, because I turned 2 in November.
He was already at PhD before.
Right?
He was already at PhD.
He was already a PhD and he was writing this classic paper. So this paper basically solves the Coulomb Bertrand with this utility function, right, with the quadratic utility function, and gets these linear demands, right, that we did, right? It gets like here the inverse demand system and then the linear demand system, and then it calculates the Nash equilibrium, and it has the answers in the table, right? So it has the price and the quantity with the quantity. And it says it has the difference in prices and the difference in quantities, and shows that the price difference is positive between Coulomb and Bertrand. So quantities are lower and prices are higher in Coulomb and Bertrand competition, regardless of whether the goods are substitutes or complements. So we also consider the case of complements. Coulomb competition is more monopolistic than Bertrand competition. Okay? So that's one of the results from this paper. But when I was working on my thesis, I was using this demand system, and I was reading these papers, and I found this paper in the Journal of Economic Theory by Jonas Heckler. And he showed this from the year 2000, from the future. He was born before the year 2000. If you So the year 2000 when I was a kid was like the future. You know, like
Oh, right, you just used before 2002. You were like,
So it says a note on price and quantity. Notes common to the rest of the editor. A note on price and quantity competition differentiated oligopolies. It says in this note we show that the results given by Hensing and X-Vives, 1984 Manual of Economics, are sensitive to a duopoly assumption. If there are more than 2 firms, prices may be higher under price competition than under quantity competition. This will be the case if quality differences are large and goods are complements. Okay, so in the case of substitutes, it won't be the case. If the goods are substitutes, high quality firms may earn higher profits under price competition or under quantity competition. Hence, it is more evident which kind of competition is more efficient. Okay? After a PhD, when I went to look for a job, I remembered these papers, and the guy that would later be like one of my bosses at this consulting firm asked me a question, you know, and he said something like, oh, right, competition is like tougher than quantity competition, and this guy was like chief theorist, you know, he was actually higher theorists because they developed like indices and how to measure the like the AJ Child, that was like a bit more modern than that. And I was like, it is in Singapore, but not. It is when you have to open, but not when you have firms in general because of Herkner 2000. And he was like really impressed by something because he didn't know what Herkner 2000, he knew what the Singapore is in our class paper. And so I think it helped me get a job, doing stuff and being like, okay, in general, this esoteric kind of more bizarre than like, it's not always true. But for them it's important, when competitions really tough and want to be pointers for consultants. Anyway, I'm not saying it's like, it's just a fun factor. When I was looking for a job, this kind of stuff helped me, like knowing this literature. Actually, because it really impressed like the hiring guy. This is another stuff. Also, another thing that impressive was that in my thesis I developed a model that there was a model in the appendix of an article journal article developing like a new index, and I developed it in my paper, and the model was almost exactly the same, except that I added like a layer of a voting model. I didn't know what the model was like, and this model was like by Salop, who was like but it wasn't the Salop model, it was a different Salop model, Salop and O'Brien. Anyway, O'Brien was like the guy that was like the theorist of this firm before this guy got hired. But then he left for the government, but right before he left, he wrote this model in the appendix of this antitrust law journal article about how to measure the anti-competitive impacts of common ownership, how to measure it. Wrote it with Salop, and then this O'Brien wrote for like the FTC, the antitrust agency. And Salop was kind of like, also a theorist, but I was like a professor. I think he's also retired now. And Salop was also kind of like my boss for a while. I worked for Salop in some cases. And in some cases, Salop was very active. He was kind of like worked like crazy. I wouldn't want to work with it, right? Basically because, and he brought a lot of business because he was like the antitrust law professor at Georgetown Law School. So he taught all the lawyers on antitrust, and then like in Washington DC, so they would call him whenever they had like some case, so people would join like law firms. So I would get like these like telecommunications cases. Anyway, that's not important. It's just like sometimes knowing these details of like this orchestration kind of details of the literature of the theory, going deep into like some literature can actually help. It seems like irrelevant because it's like, okay, people that sometimes like to know these details, the fact that you know them in the consulting world makes it look better, makes it look good. It's like if there's a guy that has been working on antitrust for 20 years and he doesn't know that there's a result published in Journal of Economic Theory 2000 that says within firms, price competition might actually be softer than public competition. Because it's like, because in the previous price competition is always tougher, but then this kid comes out of the master's program or out of the PhD, and he's like, actually that's not always the case, there's this subtlety, and some guy showed that it's not always the case. That's like, well, this kid actually did his homework, when he was doing this. And he also wrote a model that's the same as the Salop model, which is bad news for him to publish the model, because it's not innovative, but he thinks a little bit like Salop, so that's not bad. Anyway, that's why I went to consulting and not academia when I came out of PhD, because I was like, well, I guess the model that I wrote wasn't as new as I thought, and so I was like, but I know how to think about these things, I can do consulting and make money and learn about the real world, but I'm not necessarily like the best publishing. Then I came back to it, and I'm here. And then you're okay. And I published and fun.
You're alive.
I'm alive.
It's just a lot to say this time, so
It's a lot to someday, yeah. So anyway, maybe I'll tell you more stories. But now we have a lot to do because we're behind. For some reason this year I'm taking longer than ever to explain these things. I don't know if it's me or you whose fault it is. But it doesn't matter.
You don't make that question.
It doesn't matter. Maybe we just won't finish all the topics that we're supposed to see, but we'll see them in a slower way. That's fine. You know what I mean? I think I'm going into more detail in the explanations this year. Alright, so for example, like I would never think of proving this, the fact that like competition is tougher in Bertrand, right? I'm doing all the algebra of that. This year I'm kind of thinking about doing it just because I know I'd like to be very thorough somehow this year. But I won't do it. We just saw this in the US and that's it. And it's also not always true. The book, by the way,
Does the book go this deep? Because I have a PDF, but I haven't checked it.
the book is Rockoids, by the way. The book's not actually, and it's after Heckman. See, this is why like, I got the job. Because like, if you just study the book, and it says, here, lesson 3.1.1, basically shows that the pricing Kuno, that's the algebra, no? It shows that the pricing Kuno is higher than the pricing of Trant, right? In the model of differential products with linear bands. And it says, lesson 3.1.1, this is with duopoly, where it shows it. Lesson 3.1.1, price competition always leads to lower prices and larger quantities and quantity competition. Hence, price as a strategic variable gives rise to a more competitive outcome than quantity as a strategic variable, which is generally true, but it's not always true, because Heckler showed some counterexamples to that when there's not lower, and there's some complements. But that's the book that I read. Okay, it's fair that it says that, but I think that maybe we could have a footnote that says, in some cases, a complement is not true. For our purposes, the main message though is what the book says. The general price competition is very tougher than quantity competition. Okay? And kind of like in the homogeneous goods case, it's very straightforward, right? Price competition is extremely tough and it leads to price over margin cost. And quantity competition doesn't, you know, right? With two firms.
But it's a really important comment, right? I mean, come to think about it, imagine like the metallurgy industry, like every single firm or company that contributes to that stage of the process has complement goods, right? And if price competition is not necessarily tougher than quantities, then the whole understanding of the industry changes. Because many products in the industry are complements.
No, but here, yes, yeah, because it's an important factor. If you have a price competition between complements, it's a necessary competition, right? Because it's really like you have several products and they happen to be complements. And I think to talk about competition, that's why actually I think that lesson in the book maybe is okay. Because to think about like two products that are competing, I'm thinking of substitutes in general, right? If the goods are complements, they're not really competing. So maybe the language is fair. You see what I mean? If two goods are complements, it's like printers don't compete with printer ink. Right? They're complements. You buy them together. It's not like you buy one or the other. Because they're not substitutes. Okay, and then there's like, we need to do a little bit of like meta talk about what should you use in practice, price or quantity competition, right? Which one is the right one to think about?
Price, because, well, both of them.
Both, but
But aren't they related?
depends on the context, right? So when
But aren't they like directly related?
are they
Directly related?
in which way?
Like if you, maybe I'm not understanding it, but if you lower the price, you're gonna sell more, always.
If you lower the price,
Quantity is higher.
quantity is higher. No, yes, the demands are and numerous demands are related, but the mode of competition, here we're talking about the mode of competition, right? Which is the variable in the game that is the strategy, right? In Monopoly, it doesn't matter whether the monopolist chooses price or quantity, it's the same. But here, because we have strategic interaction, it matters whether the firms are choosing price or quantity in the game that we're playing. It's a different game.
Okay.
Choosing quantities is a different game than choosing prices. It leads to different outcomes. The prices are different. one is tougher than the other.
But when they choose quantity, you mean that they want to sell more units?
They always want to sell more units and they always want to sell them at a higher price. But like,
Which one
here's
is
the
focused
firm one is deciding
on?
with the quantity, right? In Kuno. And in Bertrand, firm one is deciding its price, taking as given the prices of the other firm. So mostly actually it's not about whether the firm is setting prices or quantities, it's more about is the firm one setting expectations. The reason it matters in the game, it's not really about whether the fact that I'm taking first to a condition versus to price or quantity actually. What really matters is whether I'm setting an expectation about the other firm's price or quantity, right? That's what makes it different. If my expectation is about, okay, I expect that the other firm is committed to this price, and that price is going to sell in quantity, that's a different game and a different match equilibrium than if I have an expectation that that firm is going to produce this quantity, right? And it's committed to that quantity, and then the price is going to be whatever it has to be, according to the math, inverse math. You see what I mean? Those are two different games because of the way the firm is thinking about what the other firms are going to do. Right? In one case, it's thinking about the other firm's strategy as a price, and in the other one, thinking of it as a quantity. Okay? Taking a step back. So that's what's really going on. And those two things are different, and we just saw it. Right? We just showed it. And the question is, when should I use one, and when should I use the other? And the answer is there, kind of in that thought you see. It's kind of like, it's not about whether the firms, first of all, one important insight from the literature is it's not about whether firms post prices for the products. It's about which variable is the strategic variable. Okay? And that's a bit subtle and it's not obvious ever, so there's always a debate about how to do these things. For example, airlines. Right? Airlines are very interesting industries for many reasons. But airlines are going to post prices online and then you buy the tickets, right? But does that mean that airlines compete in prices at other time? No. Why not? Because for them to compete in prices, you have to fix a price and be committed to selling any quantity at that price. Okay? That's what really price competition means. But airlines set prices because they're trying to fill planes. And they vary the prices and they have different types of prices. They do a lot of games like marketing, it's not like game theory games. They do a lot of like little tricks to try to fill the plane as much as possible with different prices. So they do price discrimination. Oh, we need to talk about price discrimination. We'll talk about that. Right? So they price discrimination, they have different prices at different times, different days of the week, different price whether you log in from a Mac or from a PC, it used to be. Now, I don't think we do anymore. Higher prices for a Mac. And so on, right? Because, but basically the strategic variable, the main strategic variable really is capacity, because they have to assign planes to routes, right? And so they have to have a certain number of seats, a quantity of seats assigned to a route, and then they move the prices of the seats to fill the plane, right? So that's like an inverse demand curve. You see what I mean? It's a P of Q. First you set the Q, you commit to a quantity of seats, and then you let the price at which you're going to sell those seats kind of fluctuate until you fill the plane. Okay? So it's a bit more complicated than this P of Q, but it's more in the spirit of this P of Q, right? The firm chooses Q. It's like we have two firms competing, and they're deciding how many planes they're going to bring to the different airports and have committed, and you have to kind of commit the planes to a different route, right? You kind of be like, I'm going to have like, I'm going to open a Pamplona, London route without having like a plane that's dedicated to that route. I mean, you see what I mean? More or less. Like, hey, the day of the flight, I'm going to sort of go and find and see like which plane in my optimization kind of like I can get to Pamplona on time. It's like I have to know there's a plane that's gonna be like going back and forth from Pamplona to London, or maybe or from Pamplona to London, and from London to Frankfurt, and from Frankfurt to Pamplona, right? But most likely it's gonna be like doing that route every day. Maybe that's in the morning Pamplona London, London Pamplona, and then Pamplona Madrid, Madrid. I don't know. It's like, but like I'm committing capacity to that route. Okay? Then I'm more in the world of quantity competition. Actually, there's, if you read the book, there's a paper, Krebs and Schenkman, 1983, which shows that if you have a two-stage game, in which first the firms choose capacity, right, and then they choose prices, and then they compete in prices, the outcome, under some assumptions, is exactly the same as the quantity competition outcome. Okay? So if you think of the airlines as first committing to a capacity in a route, and then playing the price game of Bertrand with homogeneous goods, that's sometimes gives you, under my assumptions, gives you the same exact outcome as Cournot with homogeneous goods. Okay? So that gives you the intuition that quantity competition, sometimes you think of it when capacity constraints are important and are the main strategic, and capacities are the main strategic variable. Okay? So capacity is expensive. On the other hand, for example, something like cereal, like breakfast cereal, like Cheerios, not Cheerios. You think that for the relevant ranges, they set a price of Cheerios and they're usually committed to a price because consumers really care and they don't like seeing like increases in the price, right? It could be discounts, for sometimes, but usually the firms are very committed to the prices don't fluctuate as much as for the airlines. And at that price, you can basically give the people as many Cheerios as they're willing to buy. So that's more like price competition, the cereal market. We differentiate products, right? Because you have Cheerios, you have Honey Nut Cheerios, you have Apple Cinnamon Cheerios, you have Rice Krispies, Choco Krispies.
Why you know them all?
It's a lot, right? So you have a lot of products that are fairly similar but they're differentiated and firms compete in prices. Okay? Okay, so let's just to start thinking about like when to use price competition in practice and when to use quantity competition. It's never fully, it's always a model and it's always an assumption. Maybe a question, but to get a sense of when to use one and when to use the other. It's not about, again, firms. It's not like if you see firms post prices, that's price competition period. If they have capacity constraints, capacity seems like the relevant strategic variable, the main one, maybe it's closer to quantity competition. Something that's more clearly quantity competition is like something like oil, like the oil market, right, that we talked about. Things like oil and so on, that's really important quantity. Right? That's like clearly people are bringing the oil to the market and trying to sell it at whatever price clears the market. Right? That's quantity competition period. Alright. Questions so far? Yeah?
Regarding the airplanes that you said that, okay, they fix an amount of seats and then they do price discrimination in order to sell them, but in the end, they are doing price competition because they want to cover those seats and they are gonna compete with prices. No?
They are, but they are doing first capacity, then price.
Okay, so you fix the quantity and
It's like you're first fixing capacity, setting capacities, and then you're competing in prices in order to fill the planes. That has some elements of quantity competition. I'm not gonna say it's always 100% the same as quantity, but it has a flavor of quantity competition because in the big scheme of things for the airlines, when you're looking at like the forest you know, you're looking from above, from the air. The industry is like, when they're competing, the main thing that they're thinking in the competition is how many planes is each of my competitors gonna bring to different routes, right? And I'm going to enter this route and bring more planes and have more capacity coming to my routes. And then we're gonna have to compete prices. So I know the second stage it matters, but there's this first stage of capacity competition.
So the variable the company fixes the first is kind of like the predominant characteristic, right? If you fix first the quantity or the capacity, now it's closer to quantity competition.
I would say so. I mean, I don't know, you have to get a sense of the industry and what really matters and how the firms are thinking. That's the strategies of the efforts. Question? Okay, so let's think about now. Okay, so this is the first model of product differentiation that we're gonna see. Then we're gonna see some more product in this class. Because I don't think we have time to do that. So I would like to talk now about use this model to think about sequential games. So what sequential games is when there's one firm that moves first and one firm that moves second. So far the firms have been moving simultaneously. Right? Now I want to think about a dynamic game, a very simple dynamic game, in which you have one firm is the leader and the other firm is the follower. Okay? It's just like, it's not like both firms are in the market already. It's like there's a market there, and then like the firms are well, they are in the market, but one of them is basically gonna like enter the market first and make a move, and then the other firm is going to enter the market second, after the first one. Okay? There's an order of it. Does it make sense to think about this? It's kind of important, right? Because there's always in practice like the firm that's like the first one to go. And the question is like, if you're thinking of entering the market, is it better to be the first? Or is it better to be the second? Yes. Correct. It's gonna depend on what?
On the nature of the business.
It's gonna depend on the nature of business.
For example, like England was the first one to do industrial is the revolution, but Germany being the last one to adapt to that technology change could learn of all the mistakes from France and Belgium.
Because one reason could matter is if we learn from mistakes of the first. Okay? It also depends on the mode of competition. If you're competing in quantities, it's not the same, or in capacities, right? It's not the same as if you're competing in prices. Okay? And basically the intuition is that if you're competing in quantities, the first firm can kind of like make life harder for the other firm by committing itself to a very large quantity. Right? So if the first firm is selling a lot, then it leaves less demand. There's less demand left for the second firm. So the second firm kind of strategy just has to become smaller. Okay, so the first firm has if the competition is in quantities, the first firm can commit to a very large quantity. You can have higher market share of the market, right? And higher profits.
I was trying to give myself an example of that, and I was thinking, for example, Apple could do that.
Apple did that.
Like competes in quantity. We would say that it competes in quantity rather than prices.
It's a good question.
Because you can sell.
How in the phone market?
Hmm?
In the phone markets? In mobile phone? Like the iPhone versus the Androids?
It's like the price is much higher
And
than.
they set prices, right? And they're committed to prices. Does Apple have capacity constraints over the relevant range of quantities?
Not really, the brand relies on exclusivity, right? They don't want like the whole masses to have iPhones.
Oh.
They will
cases.
I mean, when
They,
an iPhone
there's
comes out,
stars involved. My next question is, could it be that there's so many people that want to buy the?
it happens when they have a release in the States. That happened to me before when an iPhone comes out, and you look for it in any store, and they say, oh, you have to reserve, and I will give you in a month.
They
everything-
run out.
Yeah, they run out.
There could be some capacity constraints, but like that's at the very beginning. But eventually, there's enough iPhones.
Yeah.
But remember, this Apple could relatively easily produce more iPhones. You want to, so it seems more like price competition to me.
Still, I don't understand the quantity competition.
Quantity competition is when
Visualize it.
quantity competition is when firms decide how much capacity they're gonna have. For example,
Like OPEC.
like Open. Yes, that's clearly quantity competition. But then there's cases that are not as obvious, but are also like quantity competition. I mean, how? I mean, yeah, I think. Okay, let's think of an example. For example, suppose you have grocery stores, right? So if you're like in the grocery store business, I mean, you think that okay, opening a lot of stores in an area is like having a very high quantity, right? It's having very high capacity, right? And so you can think that the grocery stores compete in terms of basically investing in capacity and preempting the other stores from entering, right? So if you're the first mover, if you're like for the grocery store that came first, there's going to be less space for other grocery stores to succeed in this area, right? Because you already have, for example, Eroski and BM, right? These are mayor, or Zizur mayor, as my wife calls it.
Because she's American, right?
So you call this Zizur mayor.
So she's happy in the
So in Cisur Mayor, there used to be a monopoly of Eroski, right? There were 3 Eroskis. There's like the Uptown Organización one, Downtown Organización, and the Ardoy, big Eroskis, right? The best one. But then BM, BM, the supermarket chain opened in Ardoy, like in the Polígono, like where the Sparta is and the Teddy. You know this place? It's not that easy. It's like this kind of like industrial thing that developed. It was fairly rural, and they started this industrial thing where they put like a gym and a telepizza. I think that they opened the BM, and the BM was so shiny, and they tried really hard, but they're not. It doesn't look like they're doing very well. I don't know, but it doesn't look like they're full all the time. And so in a way, by opening so many stores in Cisur Mayor, Eroski kind of preempted a little bit the market share of BM because it has a very high quantity already. There's more going on because also it's like the thing is for more families, right? They're gonna have like loyalty programs, right? So if you buy your weekly purchase, you know, from Eroski, you have like a gold Eroski card, which I need to remind my wife when to get it, and and then you get like a certain discount, you know, like 5% discount from all your purchases, right? And then that adds up. So, but you have to pay a fixed cost for that card, like 20 euros per year, and then you save like 200, right? Per year. So, but once you paid for the Eroski card, now you get discounts from Eroski, you're not gonna start shopping at BM even if the store is very nice, you see what I mean? But that's a different story, that's a story for another day, like loyalty programs.
So, like,
But it's kind of competition because there's this physical store capacity
So
investments. They have to invest in building the stores, right? And it's irreversible.
So then in order to be quantity competition, you need like a space constraint, because if not, there's not going to be quantity
The
competition.
capacity constraint. It doesn't actually space.
Like
But
yeah,
it usually would be something related to space.
so for like Coke and stuff, like Coca-Cola, that will be kind of the Cheerios, right? Like, it's a price competition, right? Because we don't have capacity.
For Coca-Cola,
Yeah.
Coca-Cola is the classic example, the clearest example ever of price competition, right? Because how much Coca-Cola can you produce? If you lower the price today because people want to drink more Coca-Cola, how much Coca-Cola can Coca-Cola produce? Yes, like infinite. It's like I can give you as much Coca-Cola. Coca-Cola is like so easy to produce. It's like it's just like some syrup we produce out of trash or something. I don't know what we put there, and we give to people, and some people like don't drink Coca-Cola. I'm not saying that. I'm just quoting Cristiano Ronaldo. Okay, anyway. Okay, so Coca-Cola clearly price competition, right? Airlines, maybe more like capacity. Grocery stores,
Like stadiums, right? Like concerts or you have capacity constraint, you have like
stadia, yeah. Stadiums or stadia. What else? I don't know. Okay, so let's think about this dynamic competition. Let's see how it works, like how the math works for that.
Wait, one question. Would a carpooling company count as a quantity competition?
Carpooling company, like
Like taxis and
or like taxis.
yeah, like Uber.
Well, taxis are weird because taxis are weird because they fix prices, right? But like if you think of something like Uber, in Madrid, for example, Uber for the companies that like so in Madrid you have Uber, right? It sounds like it's really nice, but then it's like horrible. And every Uber driver that I talked with in Madrid, okay, I went to teach in Madrid last year because a colleague in Madrid went on paternity, and I had to substitute and I had to teach managerial economics for meetings. And so I traveled to Madrid, and this was like the last minute thing. So from there, I traveled to Madrid, and they gave me like this Uber account from the master's program, from the MIT program. And they were like, okay, yes, you have to go to like the forest, you have to teach, to like outside Madrid in Miese. And they have like this campus that's like outside the city, so you can't get there by public transportation. I always have to take the bus, I prefer it. But it's like, you can't take the bus. I did it once, it's like, and the chance that you will get killed when crossing the highway is like 50%. I'm you can do it, but it's not easy. So anyway, they're like, okay, you're gonna stay like in Chambéry or something like that, and then like, which is nice, and then call the Uber from the hotel, and they will take you to the forest to teach things. And so anyway, we're talking with Uber drivers. First of all, when you get from the train station, or the problem in Madrid is like the Uber thing is like a complete chaos, right? And the taxis are blocking the Ubers, and there's like a world going on. So that's already not very nice. And then the Uber drivers, they're very sad because when they started, everything was nice. Because there weren't so many Ubers, the prices were high, right? The rents were lower because Madrid wasn't so hot. It was always hot, but it wasn't as hot, not temperature-wise, I mean, as the city. But then, and the energy prices were lower. So it's like basically now, it's like now a ton of companies entered, and there's some companies that have like 7,000 Ubers or something, right? And they work for those companies. So the rates go down, they make less money, the rents went up, because a lot of people went to Madrid and decided to drive an Uber in Madrid. Right? Because Madrid was like the place to be. The rents went up, utilities went up, and they were thinking down. So now the Uber drivers are like squeezed. So I was like, well, I guess you come and like drive a taxi in Pamplona. But then you have to come here, move here, make that whole decision, buy a medallion in Pamplona, and so on. I mean, taxi drivers in Pamplona, on the other hand, are not very squeezed. They're doing great. They're doing great, but the medallion price, I think, has gone down because there's a threat that Uber or something like that could enter. So now taxis everywhere are like, okay, if Uber or something like, or Bolt or something like that enters, I think Bolt just did it. And then, I don't know if they know, because these things, for the taxis, it's such an equilibrium thing, a kind of, I'm very pro-freedom. I'm not very pro-freedom. I like to think that I'm very pro-freedom, and then I'm not. You know what I mean?
When you see the consequences of freedom, then you're like, yeah,
Exactly.
no.
It's like I'm old enough to not be. So pro-freedom or pro-communism or pro-anything. Like, show me the product and I'm like, no. Okay. Okay. I've seen enough. Okay, bottom line is like, okay, these Uber companies decide how many cars they're gonna buy, right? And it's not real. So it's like a capacity decision, so it's more like quantity competition, how much quantity of Ubers are gonna supply, and then the price, Uber is kind of like the inverse demand function, and it tells you what the price is, depending on how many Ubers there are. And you could think, okay, yes, then the price varies depending on the time of the day and all that, but then just think of the average price of Uber rides, right? In a given month is going to be a function of the number of cars that are there in the market, right? So the different firms decide how many Ubers they're going to buy, how many cars they're going to buy to convert into Ubers, quantity decisions, and then that determines the price level for Uber in that year or in that month. You see what I mean? That's quantity competition. I'm thinking of here not about Uber. Uber is the platform. The platform is the inverse demand function, right? And then they take a little cut, of course. But then the firms that supply the Ubers, and maybe there's like an individual fringe of individual drivers, but the firms that decide, okay, I'm going to bring 7,000 Ubers to the market, and I'm going to bring 5,000 Ubers to the market, those are like no firms competing in quantities. Does it make sense now? Quantity competition? It's brutal. But price competition is even more brutal. Except in the cases that Heckler pointed out, in the theory.
So quantity competition is like more difficult to, once it's established, than to change the game. Like, I mean, no?
Quantity competition is?
Like, more difficult to compete in. Like, once there is like 3 competitors, imagine, like another one to enter in the competition is tougher than in price competition.
No, not necessarily.
No?
Well, it depends. It depends. Maybe it's a good question. What does it mean for? Because yes, the competition is tougher in prices, right? Because the prices are going to be lower in equilibrium. But with enough symmetric, sequential, not sequential, right? Simultaneous, right? But in sequential play, if there's already one firm and it's quantity competition, it is tougher for the follower. It's worse for the follower. But if we're in price competition and there's sequential, if there's already one firm and it's committed to a price, then it's easier for the second firm to enter, even though price competition is already tougher. So it's kind of paradoxical. But in a way, yes, if there's already like firms that have bought all the cars, right, and they're committed to this big quantity of Ubers, it's harder for me to now go and buy like the same number of cars and not compete. But if there's Coca-Cola and they sell Coca-Cola at, I don't know, $2 per liter, then I can go and sell Azar Cola at $1.99, right? And maybe it's easier for me to do that than in the quantity competition case. Good? Okay, now let's see it mathematically. one firm that's going to be the leader and one firm that's going to be the follower. Okay, so let's think of Kuno. Let's think of P1 of Q1 and Q2 and P2 of Q1 and Q2. Sorry? Right? And let's say they have the same margin cost. One equals to C. The profits of firm 1 are equal to P1 of Q1 and Q2 times the quantity, or let's say minus the margin cost times the quantity of firm 1. Right? And then the profits of firm 2 are equal to the price of firm 2 as a function of Q1 and Q2 minus C times the quantity of firm 2. So how do I solve this model if basically first from 1 chooses Q1 and then from 2 chooses Q2 and then so T equal 1, T equal 2 and then T equal 3 profits are realized. Like when the consumers in the price is set and profits are realized. How do I solve this?
Who decides first? Ah, sorry, firm 1. So.
No convention. Backward induction. Okay. What does that backward induction mean in this context?
But first we have to see how maximizes firm 2 and in terms of that how firm 1 will act.
Right. First we have to solve the problem of firm 2.
Yeah, we have 1, 2, 2,
Okay.
and then we sort to
Okay, backward induction here means we're going to maximize this, right? So that's going to mean we're going to do delta pi 2 over delta quantity 1 is equal to the derivative of this, which is delta p2 over delta, no sorry, delta pi 2 over delta p2 over delta p2 plus p2 minus c times delta p2 over delta q2 is 1. This times q2. Okay, this is the same first order condition as in Coulomb. And then from this, when I solve this equal to 0, then that gives me the reaction function from 2, right? That's going to be Q2 as a function of Q1. In general, right? Generally speaking. If I were in linear demands, homogeneous goods Coulomb, this would be equal to A minus B1 minus C, right? That is our 2, right? In the case of this is in linear homogeneous case. Okay, in general, we're going to get some Q2 as a function of Q1. And now what about from 1? Now we have to, we solved the last step, and now we have to go to the first step, right? We're going backwards. So now from 1 first order condition is delta I1 over delta Q1. And what's the derivative of this with respect to Q1?
derivative of the first, the derivative of the price times the quantity plus the price also.
Shouldn't you just like replace Q2 by that expression and then just derive with respect to Q1? Isn't that like backward induction? Or we first derive and then we replace?
Well, we have Q2 as part of Q1. We have to take into account here, I mean, that Q2 here is not fixed, right? It's going to depend on Q1, right? So when I'm taking this derivative of this with respect to Q1, it's going to be the derivative of P1 with respect to Q1 plus the derivative of P1 with respect to Q2 times the derivative of Q2 with respect to Q1. Okay, and then I do this whole thing times Q1, right? This is what I'm saying. How's my price going to change if I increase my quantity? Well, if I increase my quantity, that is going to have a direct effect on the price, right? Through the demand function. But then if I increase my quantity in the next stage, that's going to affect the first order condition and the best response function through the first order condition of from 2. So it's also going to affect the quantity that from 2 is going to decide in the second stage to go. And that's going to enter my demand function as well and have an effect on my price, right? So it's going to have a direct effect and then an indirect effect through Q2, right? So that's delta P1 over dQ2 times dQ2 over dQ1. So this is the change in the price, and I have to multiply that times the number of units that I'm selling, right? That's how my profits are going to change. Change in the price times number of units, marginal revenue of changing my quantity, and plus P1 minus C. Okay? Of course, if I increase my quantity by 1, I also get the price for that unit, right? So the overall marginal revenue is this, including this P1. And then I have the marginal cost, right? And this is equal to 0. So this one is the same, but here there's a new term, which is this one. Okay? New. And this new term is going to imply that from 1 is going to produce more than before. Because is this new term positive or negative?
Positive.
Depends on the derivative.
Well, I mean, the change in Q2 over the dQ1 is the slope of the best response function in Coulomb, which is negative.
So it's negative.
So it's negative, but then this dP1 over dQ2 is also negative. If the other firm increases quantity, my price goes down because they're substitutes, right? This one's negative because they're what's called strategic substitutes, means like the slope of the best response is negative. This one is negative because they are substitute goods, okay? Which means that if the other one increases the quantity, my price also goes down. And negative times negative is positive.
So what is
So this is positive. Sorry?
What is the second term negative?
This one?
Yes.
Because in Coulomb, the best response function has a negative slope. Remember? It's like the graph in Coulomb is like this. Right? These are the best responses, remember? And this is the Nash equilibrium. These are negative slope. And if that long term is positive, that means that the derivative of profits with respect to quantity, when evaluated at the old quantity, when evaluated at the Coulomb quantity, all of the other terms are the same as in Coulomb. So the old terms, when I evaluate them at the old quantity, they're going to be equal to 0, right? Because that's the first order condition for the old quantity. Right? Basically, the old terms are going to be equal to 0. So, okay. If I evaluate this first order condition at Q1 equals Q1 for no, then that's going to equal to dP1 over dQ1 times Q1 plus Q1 minus C plus the new term. This is the old stuff. Plus dQ1 over dQ2 times dQ2 over dQ1 times Q1, right? This here, this is the old, this is the Coulomb first order condition, okay? Which is equal to 0 at the quantity of Coulomb, at Q1 equal Coulomb. And then this is less than 0, this is less than 0, this is also less than 0, so, and this is greater than 0, so this is going to be greater than 0. And therefore, at the Coulomb quantity, if I consider increasing my quantity by 1 unit, what does it do to my profits?
Q by the change in the price of one times your food.
My profits go up, right? So I'm going to choose to produce a higher quantity, okay? So Q1 is going to be greater than the Coulomb quantity, okay? Because of the Coulomb quantity, I want to increasing the quantity increases the profits, right? So I'm going to produce more. You see what I mean? You see the reasoning?
So this is staggered, no?
This is staggered,
It
okay? This model is called staggered. Okay. Staggered verb, okay, which is basically Coulomb, but one firm plays first and one firm plays second. And we can do this with linear demands and homogeneous groups too.
So in terms of welfare, the results are better, right? Because than the Coulomb, because we end up producing more. Or I'm wrong.
We end up producing more, so it's better for consumers and for all the world. Yes.
Produce more quantity for the consumers and more profit for the
Let's do staggered growth. With linear demands and homogeneous. Okay, now we can say P of Q is equal to A minus B times Q. Okay, where Q is equal to Q1 plus Q2. Okay, so now let's back to the homogeneous case. Nice. Easy.
You?
No, this is nice. What's nice is the homogeneous case.
Mm.
You? I don't know if you I mean, no, true, but I know you.
That's okay.
Siemens. But you never know. Be careful these days.
These Peruvian people, you can trust them.
My Bible class.
Okay, so now let's do that, but with the linear demands and homogeneous product. Okay? So remember, backward induction, right? So from 2, we're gonna get that Q2 is equal to A minus B. This one, and just to be clear, just to close this whole thing, I'm not accusing you of anything. I have no evidence that of any wrongdoing by you. It's just
I mean?
forget it. Okay, this minus C, right? A minus B1 minus C over 2. Okay, that's because it's the same as in Q now, right? But then, so this is Q2 as a function of Q1, right? This is the best response. From 2. And now for 1 has to do profits from 1 are equal to A minus B times Q1 plus Q2 of Q1 minus C times Q. Okay, so the first order condition from 1 is going to have this extra term that is going to include the derivative of the best response of from 2. Okay, so that's going to be A minus 3B Q1 minus C minus B times Q2. That's the old one, right? That's what we had before. Minus B times delta Q2 over Q1 times. Okay? This is the slope. Delta B1 over Q2 over Q1. That's B. Then this is the slope of the reaction function, and then this is the coefficient for 1. Okay? And what's the slope of the reaction function? The slope of the reaction function is equal to the slope of this, which is 1/2. Right? It's minus B over 2B. So this is minus 1/2.
In this case, if I'm not wrong, the leader is gonna have to produce the double of the bottom.
In this case, the leader is going to be double of the column. So this is equal to 0. So this is going to be like plus B over 2 times Q1. So here instead of having a 2B, right, I'm going to have 2B minus 1/2 times B, right? So it's going to be 3/2 of B. So I'm going to have A here. A minus 3/2 of B times Q1 minus B times Q2 minus C is equal to 0. And now we also have to substitute this Q2 into the Q2 there. So it's going to be A minus 3 halves B times Q1 minus B times A minus B times Q1 minus C over 2B minus C equals 0. So now we also have to add here this B cancels out with this B, so it's going to be minus A over 2, right? So it's going to be A minus A over 2, so it's going to be A over 2. Q1, here we have another plus 1 half, right? So minus 3 halves, so it's going to be like minus B times Q1. And here we have plus C over 2 minus C, so it's going to be minus C over 2 equals 0. So it is like A minus 2B Q1 minus C equals 0. Okay? And therefore, Q1 is equal to A minus C over 2B. And Q2 is going to be substituting this into the reaction function. Okay? It's going to be A minus B times that. So it's going to be A minus C over 2 minus C over 2B. So that's going to be equal to A minus C over 4B. Stack up. Okay, so if you look at this, basically, the leader is producing the monopoly quantity.
I'm sorry.
C.
Yeah.
Tell me, like, that seems familiar, like 20 minutes ago.
It's the monopoly quantity, right? Because the quantity in general in monopoly is like A minus C over N plus 1 times 2.
Yeah, yeah.
And if 2 is N plus 1, then that means that N is 1. Okay, and then this is like producing half of that. And then profits, the profits of firm 1 are going to be equal to B times the quantity of firm 1 squared, and the profits of firm 2 are going to be equal to B times the quantity of firm 2 squared, right? So the quantity is half. This one's going to be making 4 times as many profits as firm 2. Okay? And that's what we call first mover advantage. So in quantity competition, it's better to be the first to get to the market, produce a very large quantity, as if you were the only one there, ignoring any potential other firm that could enter. And be a winner, right? And have the first mover advantage. Okay? Kind of like in Cobra Kai, strike first, strike hard, no mercy. You know this series?
Yeah. I've seen that.
No? Nobody has seen Cobra Kai?
Wrong audience.
Wrong
It was
audience.
a very good joke. Like it was a solid joke. I've seen it with my brother.
But this is only at the quantity competition, it's not always true in life. okay? So I don't want you guys going there and starting fights or anything. Be more like Miyagi though. And also, Miyagi though is right for prize competition, as we will see next class. You guys, nobody has seen Cobra Kai? You've seen it? Cobra Kai? You have? Okay, it's, okay, this is, okay, there's a movie called Karate Kid, right? Have you guys seen Karate Kid? Right? Remember Karate Kid? Did you watch Karate Kid? So, what was the plot of Karate Kid? Karate Kid was like,
The underdog.
it was the underdog, right? So he was like this poor kid that came from New Jersey in this like old car with his mom, and they went to live to California, right? But California is really expensive, so they went to live to like this really bad apartment, right? In this bad neighborhood called Reseda, right? And then there was the blonde rich kid in his high school, right? And then he was like, he had like this blonde girlfriend, and then like he went and he like went there and like kind of stole his girlfriend, and then the blonde kid started bullying him, right? And then he went and learned karate, and then he went and won the karate tournament, and he was the hero, right? And everybody cried. But then these guys made like a YouTube video, being like, no, actually, Naruto, you know, the poor kid, was the bad guy of the movie. And they're telling the whole movie from the point of view of the blonde guy. Right, and he's like, look, he was just there hanging out with his girlfriend, you know, having a time on the beach, and then this guy comes out of nowhere, and then suddenly starts like immediately trying to pick him because he's jealous of his girlfriend and this kind of stuff, you know, and everything is instigated when you see it from this way, and they're kind of right by Larusso, right? And so it's kind of interesting because it was this kind of feel-good movie, but suddenly this guy makes very good points, and actually, if you see it from the point of view of the blonde guy, it's not so clear, right? Who was the good guy and who was the bad guy? And so the guys came together, the blonde guy, the actor, and the actors from Cobra Kai. Now they're old, and they made it a Netflix series where like everything's about, it's not clear who's the good guy and who's the bad guy. You see what I mean? And then basically there's like now a new cast of like younger teenagers, right? And then they become like the dojo teachers, right? And so they create competing dojos. Cobra Kai, and the other one was honoring Miyagi, you know, who was like this old Japanese kind of like wise man that taught him karate. He didn't have a dojo, but he started the Miyagi dojo. And basically they have opposite philosophies. Cobra Kai is like strike first, strike hard, no mercy. First more advantage, and then the other one's like defense only. Anyway, it's a good series. Watch it. It's not going to help you at all. The industrial organization. All right. Classes, please.
Okay, see ya.
Profit function is igual to profit function.
It's B times E plus square.
Right.
So how
Profits are always big times the profit.
So the B function, so the B for the short one is the large.
Pero